Electromagnetic guitar, chord playing support system on guitar by Electromagnets. Introduction. In this research, we introduce electromagnetic guitar, a new guitar interface that supports chord playing mainly for beginner guitar players. In the case of right-handed players, they play the guitar with their left hand's fingers on a fretboard and pick the strings with their right hand's finger, and our EMG guides the player's left-handed fingering by magnetic force. To realize such a concept, we made an original fretboard with controllable electromagnets mounted and attached it to a normal classic guitar. EMG draws players' left-hand fingers with iron plates attached toward proper chord positions on the fretboard. Generally, guitar beginners cannot press a string correctly when playing a guitar chord. This is mainly because the muscles and nerves of the middle and ring fingers are not independent of each other, making it difficult to make the correct chord form. We propose EMG for the purpose of supporting beginners' fingering of a guitar from a body control approach. Related works. There are many devices and systems previously proposed that enable performers to augment their guitar playing. For instance, BioStomp uses biosignals to increase input channel for controlling effector knob while playing the guitar. And MagPick uses electromagnetic interference between magnetic pick and guitar pickup to extend guitar playing expression. On the other hand, many devices and systems that directly control users' hands have been proposed in previous studies. Haptic Marionette proposed a method for controlling human hand posture by combining electrical muscle stimulation and hanger reflex. Additionally, Mountain Guitar is a compact guitar that can be played by everyone, such as beginners and children. With reference to these related studies, we propose EMG for the purpose of supporting beginners' fingering of a guitar that requires delicateness with a real guitar from a body control approach. Proposed method. This figure shows the structure of EMG prototype. This prototype was created to test how effectively fingers could be pulled toward a specific limited low chord. We made an original fretboard for embedding electromagnets. Our fretboard consists of a medium-density fiberboard. 18 holes are drilled into the MDF board by laser cutter for embedding electromagnets. Our electromagnets are composed of iron core and enamel wire. We used an assembly screw as the iron core. Electromagnets were embedded into the 3 positions pressed by the chord C, and dummies were inserted in other positions. The position of each electromagnet can be changed manually. The figure of circuit shows how the electromagnets are controlled. Each electromagnet can be switched on and off by the Arduino. 3 volts dry cells power each electromagnet. Solid-state relay is used to prevent Arduino from excess current. In order to use the magnetic force of EMG for string pressing, we fixed a thin iron plate on each fingertip and wrapped them with a rubber finger sack. This slide is the overview of our proposed method. Thus, we made EMG prototype by designing following the 4 parts: electromagnets, original fretboard, fingerstall, circuit. This is a prototype demo movie. The 3 electromagnets embedded in the position of code C are turned on and off every 2 seconds. As you can see, the fingers are slightly pulled toward the chord position by the magnetic force. User study. With 24 participants including 7 experienced and 17 inexperienced persons, we conducted an informal study to test how effectively fingers could be pulled toward C chord position. The study took 10 minutes on average. After a brief verbal description of the system, the users were given about 5 minutes to play. Then the participants were asked to answer 4 subjective questions, which consisted of Q1. How was the power to draw your fingers? Q2. How was the power to keep your chord form on the guitar? Q3. How about the comfortableness of EMG, like heaviness of the body and thickness of the fretboard? Q4. How was the heat generation of the guitar? Lastly, the experiment ended with free feedback from participants. This graph shows the result of Q1 and Q2, which are about magnetic force of EMG. As for magnetic force to draw, 1, 16, and 3 participants reported it to be adequate, weak, and absent respectively. As for magnetic force to keep chord form, 19 people reported adequate magnetic force to keep their chord form. Regarding Q3 and Q4, 4 people reported a feeling of discomfort when holding the fretboard because of its thickness, and no one pointed out the prototype's heaviness or heat generation. Discussion. Magnetic force. As a result of magnetic force, there is a big gap in magnetic force between draw and keep their finger. Specifically, our EMG prototype offered sufficient magnetic force to keep chord form despite the weak power to draw fingering. The weakness seems to be caused by the exponential decay of magnetic force according to a distance between the electromagnet and the fingerstall. Thickness of the fretboard. As for the thickness of the fretboard, 4 people reported a feeling of discomfort when holding the fretboard. One of the solutions is to make it thinner by embedding electromagnets into a normal guitar fret. Differences between experienced and inexperienced person. From the experimental results, it was found that experienced people tend to feel less magnetic force than inexperienced people. We assume this is because the experienced person physically remembers how to use the muscles of the fingers, wrists, and arms to press the chord, and the muscles are working properly when the chord is pressed. On the contrary, it seems that inexperienced persons do not know how to apply the force necessary for string chording, so they are naturally in a relaxed state and are relatively susceptible to magnetic support. About the 4 people who answered others. There were 4 people who couldn't answer the question about EMG's ability to pull fingers. The reason was that the pulling force changed and could not be determined uniquely. We assume this is because the magnetic force decreased with the gradual fall in power. Also, there were subjects who held the guitar with a unique chord form and who had small fingers and did not reach the strings. Limitation as the performance supporting tool. The existing EMG system has limitations as a performance support tool. For example, a finger sack attached to the tip of the finger makes it difficult for the finger joint to bend and uncomfortable to play. In addition, flexible fingering becomes difficult, so you can't use performance techniques such as slide and pulling off. Also, in the informal user study, the nut and bridge for raising the string height often came off by the tension of the strings for standard tuning, so the correct chord sound could not be output. This was due to the weak fixing of the nut and bridge. Therefore, it is appropriate to use it as a performance support interface for a beginner to learn how to press a chord. Conclusion. We introduced a new augmented instrument named Electromagnetic Guitar that realizes easy chord playing on the guitar by using electromagnets. Specifically, we designed the guitar interface concept and made a simple prototype as the first step to realize the concept. As a result of our user study, participants reported EMG potential of chord supporting, especially in chord form keeping, though not having enough power to properly draw fingering. We plan to improve upon issues such as weak magnetic force and comfortability in the future.